So let us continue. In this part, we consider a Heaviside function. Which is a branch function defined as h of x equal to 0 for any x smaller than 0 and will be 1 if x is larger or equal to 0, right? Look at this. The question is, what is the limit of h of x as x approaches 0? Okay. Before doing this, let us graph this function and see how it looks like. So this is the y-axis, and this is the x-axis. The Heaviside function here, for any x smaller than 0, h of x should be 0. It means it is this line, right? And it's identical to this. And for any value of x larger or equal to 0, y will be 1. If this is 0, this is 1. So this is our function h of x. There are two branches. And this guy, right? So you see that when x approaches 0 from the right, we get what? From the right, here going to this, it means is go close to 1, right? Similarly, when x approaches 0 from the left, we get, is it from the left? What is it? Go here, boom, 0. So, by definition, limit of h of x when x goes to 0 does not exist. because it exists when f of x approach only one value, is x comes to 0 from both sides, right? But it is not the case here. When it goes from the left, it becomes 0, and x goes from the right, f of x becomes 1. So the limit does not exist in this case. Sometimes using numerical method, and calculator, might get wrong answer. So be careful. Your job is to read example 2, example 3, in section 2.2 from the book, right? Furthermore, instead of writing this long sentence, we want to make things simpler by writing this way. Okay, limit h of x when x approach from the right, it means that we can write it x go from 0 plus. It means the right side of 0, right? And we know this value is 1. A shorter way instead of writing this long sentence, right? And here, similarly, let us write it this way, implying that x go from the left side of 0, which is 0 in this case. Okay. This example leads us to a definition of one-side limit. Okay. So we define the left-hand limit. Or in short, LHL of fx is x approaches a is equal to L if we can make the values of fx arbitrarily close. to L by taking x to be sufficiently close to A with x less than A. Or you can see, suppose this is the real line, right? This is A. So from the left side, for anything smaller than A, we call it a negative. And for any numbers going from the right side of A, we call it a positive, right? So we write it, limit fx when x goes close to A from the left side, it is L, okay? Or similarly, the right-hand limit is similar, which we write it, limit of fx is x approaches from the right-hand side is equal to L. Remember, limit of fx when x approaches A if and only if this is equal to L, if and only if the limit of fx when x approach the left side of A should be equal to L, and limit of fx when x approach to the right side of A should also be equal to L, right? If and only if, be careful. Okay. Here is a visualization of how the left and the right hand limit of a function f. On the left, the graph here, the purple one is the graph of fx. It is defined for any values f of x smaller than A. We see that when we goes from the left side of A, the value of fx approach to L here, right? So it means that limit of fx is x approaches a negative is equal to L for this figure. Similarly, when x go from the right side of A, the right-hand limit of fx in this case is L. Okay. Now, let us consider an example. Obviously, it takes a lot more time to move these guys. Okay. Now, look at this example. We are given a graph of a function y equal to g of x, which is defined in two branches. The first one is for any value of x smaller than 2. This is the first branch. And the second branch is for value from 2 to infinity. But remember, at x is equal to 5, the function is defined at this point. So we see that the solid point is the point that belongs to the graph. The point with a hole here, it means it does not belong to the graph. So now we can write all the limit of this function, as we can see, observe this from the graph here. Now, what is limit of g of x? As x approaches the left side of 2. What is it? Correct. When x go from the left side, the value of fx approach this value, right? And this value is 3, right here. Right. Therefore, the left side limit of g of x when x approaches the left from the left of 2 will be 3. Similarly, if x goes from the right side, then the limit of this should be going to this value, right? In this case, it is 1. You see it? Very good. Okay, at 5 is trickier. Now, see the limit of g of x when x approaches the left side of 5 should be going this way, right? Right here. And from the graph, we know that this value is 2, right? Right here, this guy, it should be 2. And the same story, limit of g of x when x approaches the right side of 5 should be the same things, right? Should be 2. However, the value of g at 5 is given by this point, which is 1. What can we say about this? So we see that the limit of g of x when x approaches 5 is 2, because the limit from the left and the limit from the right when x approaches 5, they're both equal to 2, then limit does exist. Right? At x approaches 5. However, this is not the value at 5. So be careful in the future. How about the limit when x approaches 2? Does it exist? No, definitely no. Because limit of g of x when x approaches 2 from the left is equal to 3, which is different from the value of limit of g of x when x approaches from the right-hand side of 2. This is 1. These two are different. Therefore, limit of g of x when x approaches 2 does not exist. Be careful. Okay, very good. So this is a concept. Now, let us take a look at these examples. Give me a second. Right there. Okay, now let us consider this example. Limit of f of x when x goes to 0. What is it? If f of x is 1 over x squared. Okay. Let us make a graph of this. By graphing it, we can put some values. When x is equal to 1, then what is f of x? It will be 1 over 1 squared, which is 1. How about x of 0.5? Then f of x will be 1 over 0.5, right? Which gives us 2. Do it similarly. We know that the graph of this function should be like this. Somehow like this. Symmetry with respect to the vertical line. It's not very good graph, but yeah, here we go. Okay, this is f of x 1 over x squared, which is two cases. When x is positive, then f of x is positive. X is negative, f of x is also positive here. We see that when x approaches 0, f of x becomes a very large number. You see, when x goes to the right side of 0, right here, f of x becomes very large on top here. Similarly, when x go from the left side of 0, f of x will be also a very large number going up here. So, and f of x, we see that it does not approach to any fixed value. So in this case, we say that the limit of f of x does not exist near f x is equal to 0, and we denote it as limit 1 over x squared when x approaches 0 is infinity. Infinity here is a very big number. We don't know what it is, but we know that it is very big. 1 million? Yeah, somehow, but yeah, it's even bigger than that. 2 million? Bigger than that. Yeah, any arbitrary big numbers. And we write it like this. Limit of the function f of x as x approaches a is infinity. Okay? And now let us consider these graphs. Okay, the first graph here, graph is the blue one right here. When x go from the left side of a, f of x approach a very big number is on top right here. This is this guy, limit of f of x when x approaches the left side of a will be infinity. And similar story, if x go from the right side of a is in the second figure on top, on the right, will be this guy, will be infinity. Or if x goes to the 8 from the left side and f of x becomes a very small number, negative infinity, going down this way, we write it limit of f of x is equal to negative infinity when x approaches a minus. And the similar story, limit of f of x as x approaches from the right side of a is equal to negative infinity as in this figure. Okay? So these guys, the blue line here at x is equal to a in all these graphs, or this guy, or this guy, or this guy. All these, we call it a vertical asymptote. definition. The line x is equal to a is called a vertical asymptote of the curve y equal to f of x if at least one of the following is true. The first one is limit of f of x when x approaches a in general is equal to positive infinity, or limit of f of x is x approaches a plus is equal to infinity, or the limit of f of x is x approaches a minus is equal to infinity, or limit f of x is x approach a is negative infinity, or limit of f of x is x approaches a plus is negative infinity, or the last case f of x is x approaches a negative is equal to negative infinity. Okay, let us move this guy here. Oh no, leave it this way. Okay, still okay. Then these are asymptotes, as you can also see in the previous example about the graph. Now, let us consider these examples. Limit of 2x over x minus 3 is x approaches 3 plus. It means from the right side. And the limit of 2x over x minus 3 is x comes close to 3 from the left hand side here. Okay. Now, in order to see this, we need to plot the graph of this. And we pick some value of f of x, some specific numbers near 3, you see it. 2x divided by x minus 3 you see that this is the graph when x is equal to 0, then y would be equal to 0. It goes up here, somehow like this. And here, you see, somehow like this. And this line graphic, you see it. This line it does not cut. This is x at 3. So we see that when x go from the left hand side of 3, it will be going to negative infinity, right? This is the graph of 2x over x minus 3 would be this guy and this guy. And the other way around, when x go from the right hand side of 3, it will be going to positive infinity here. Yeah, see it, right? So let us consider another example about the natural log function. Limit of natural log of x is x approaches the right side of 0. It should be negative infinity. It's easy, right? Do you remember the definition of a natural log? So, natural log of x, which is the log base e of x, right? Which, and when x goes to positive infinity, it means we need to ask ourselves if this guy, if it is equal to b, for example, which means x is e to the b. So in our case, which values of b here to be 0 equal to e to the b? Definitely in this case, b should be negative infinity, right? Okay. So, and the graph of natural log function, if you remember, this is the inverse of e to the x. Suppose this is the Cartesian coordinate, x and y here. The natural log function will be somehow like this guy. goes here. It is x is equal to 1, y will be 0. So we see that the y-axis, or at x is equal to 0, is a vertical asymptote of our problems. Okay? If you don't remember natural log function, try to review it yourself. Thank you so much. And remember to do the homework 2.1 and 2.2. Thank you.